Apologize to Gracie. She's on Facebook. You can post on her wall.
How is this? What?
I guess leaving her in the ground to sleep instead of playing golf. I gotta take all this. This is your fantasy with me in it. All right, hold on. What was I supposed to do? All right, got it. So we're supposed to write this function. Make count LOS. Yeah, like a count. Yeah, that sounds good. This is going to be a lambda. It's going to take in a list of symbols, and then we need to ultimately return a new list. Correct? First thing I'm going to do is I'm going to write a function here. That's pretty fun. Jammer sent me a text of a swastika. Wasn't an image. He did it with text. I like creativity. Okay, so we're going to define create count list. KK, thanks. To be a lambda, it's going to take in a list of symbols as a parameter. And we'll create a cond null list of symbols. No, actually, it's not gonna. This will be funny. List of symbols 2. I'm gonna take in 2 lists of symbols. Oh, this would be a cool solution. Oh, you're like this. You're gonna like this. All right. So this create count list is gonna take in 2 lists of symbols. So null list of symbol. Return the empty list. Else, let me close all these parentheses real quick. I'm going to write another helper function. Define count symbols to be a lambda that takes in a list of symbols, and it's going to return, let's see, it's going to take in a symbol. Let's call it count symbol. Take in a symbol and a list of symbols. And we're going to create a cond null list of symbols 0 else plus 1. Actually, nope, sorry. EQV, car, LOS, and S, if those guys are equal to each other, then plus 1 count symbol cdr, count symbol S and cdr list of symbols. So if the symbol I'm currently looking at is the symbol that I'm trying to count, add 1. Else, just call count symbol S and cdr list of symbol. So that guy should boil down to the number of times S appears in list of symbols. That's what that function should do. So create count list. What I'm trying to accomplish with that is I want to build something that looks like this. I'm trying to generate a list of numbers that has all the counts in it. So it's kind of like parallel arrays. So in the end, I'll have these 2 lists, the list of all the symbols, the list of all the counts. Does that make sense? And then I can merge them together. So to accomplish that, we're going to take in my list of symbols, but I'm going to take it in twice. That way I have the full list of symbols, and I can whittle down my list of symbols. All right, so If my list of symbols, which this is the guy I'm going to whittle down, so my list of symbols 2 is my permanent list of symbols. So here I can even call him unchanging LOS. So I'm not going to change that guy. I'm going to whittle down LOS, but not going to change unchanging LOS. So else, I'm going to cons whatever's returned from count symbol, passing it the car of LOS, and unchanging LOS. I'm going to cons the return of that onto create. Here, let me just kick it down a line. Create count list cdr LOS and leaving unchanging LOS alone. No, I didn't. See? Durr. All right, so there's create count list. Now, just for time being, let's test both of these guys. So I'm going to say, let me steal this guy. So now when I call create count list, I'm going to pass it the list of symbols twice. It's going to take in list of symbols, unchanging list of symbols. If my list of symbols is null, return the empty list. Else, cons, calling count symbol on, let's call count symbol here real quick. Count symbol A on the list of symbols. Oh. Is that right? There's my 3. B should be 2. And C should be 1. All right. So back to create count list. I'll take in 2 lists of symbols. If my list of symbols, LOS, is null, just return the empty list. Otherwise, I'm going to cons whatever's returned by count symbol, passing it the car of list of symbols, which the very first time through would be this A, along with my unchanging list of symbols, which should be this entire list. I'm going to cons that onto, and we've seen that this guy returns the 3 or the 2 or the 1, depending on which symbol I pass in. I'm going to cons that onto create count list, the same guy here, passing it the cdr of my list of symbols, so 1 smaller, and passing it my unchanging list of symbols. So that gets me this list, 3, 2, 3, 1, 3, 2. 3, 2, 3, 1, 3, 2. Make sense? So I built a parallel list, a list with the exact same number of elements in it as my original list. So now I just have to walk through either one of the lists. I know that as I just keep taking cdrs, they'll empty out at the same time. And building lists out of the cars of each. So last part will be define merge lists to be a lambda that takes in a list of symbols and a list of numbers. And I want the symbol to come first. Yep. Okay. Cond null list of symbol. Turn the empty list. Else cons the list version of the car of list of symbol with the car of list of number onto merge lists. Kick it down a line. Merge lists of cooter list of symbol, cooter list of number. So this is the guy that actually merges the two. And then finally, define quiz to be a lambda that takes in a list of symbols. And all this guy does is call merge lists on list of symbols and create count list, list of symbols, list of symbols. So there's my answer, A3, B2, A3, C1, A3, B2. All right, anybody do it substantially differently? Go ahead.
Well, I just tried to do it for every, like when I found a symbol, I tried to just replace it with how many times it's found.
Okay.
So I didn't create the list of numbers, I would just like kind of search them.
Right, so let me kick back here real quick. So you were walking through this first list, right?
Yeah.
So when you got to this A, you tried to replace that A with the number of times it was found?
So yeah, I think that A3.
Right, yeah, no, I get it, but weren't you whittling down this list?
Yeah.
So
Well, yeah, I was like passing it like kind of with helper functions, like a whole list, and then the list that's been whittled down.
okay, so you kind of did what I did where you were passing two lists around. One that you weren't changing and one that you were whittling down. Okay, because the problem with whittling it down and not keeping track of an unchanged one is first time is there's 3 A's, second time there's only 2 A's. You start running out of A's as you whittle it down if you're counting it. All right, anybody else? Go ahead.
I made like a global variable / list called the answer that I would edit.
That I hard coded to this, and then I just displayed that. Okay, so you made a global variable. So you did something like define answer.
Yeah.
Okay.
It's just an empty list to start off with.
Okay.
And then I just edit that. That way it wouldn't have to. It's less code that I had to make.
Oh, so you always referred to this
Yeah.
to count.
Yeah.
So it's this guy that didn't change. It's not that you edited it, you counted this.
No, like, instead of like, how am I trying to say? The answer was the thing that I made.
Instead of building it recursively as you were going through it, you made a separate call to add to a global variable symbol and the count.
Yeah.
How did you add to a global variable?
Cons.
But then did you change the value of the variable? Like, let's say, so you start off with define blah to be the empty list.
Yeah.
Something like that. How did you add to that? You said cons. So you cons what onto, so you might say cons 3 onto blah.
Sure.
But did you change the value of blah after that? Or did you just kept building this up?
Yeah, it's good building it up.
All right.
That's what I tried to do at least.
Gotcha. Sounds like kind of a waste of time.
Well, it probably doesn't work.
Yeah, it's like you used a variable instead of just creating the recursive cons that ultimately ends up with the empty list. Okay, what else? Anybody use the parallel list type of idea? Okay, so that would fall into another programming pattern type thing to consider. Parallel lists, parallel arrays are a way of solving problems. So the second you saw this problem where you needed to take this as a parameter and ultimately produce something related to each element of this list, creating that secondary list with the counts in it should have probably popped into your mind. So think about that from a pattern perspective. I need just as many counts as I have symbols here. So since I need just as many counts as I have symbols, why don't we go ahead and let's create all the counts? Because once I have the counts and I have the symbols, I can merge them together pretty easily. Make sense? All right. See, so easy quiz. Any questions about this before I just delete this file? I'm not even gonna, I'm just not gonna save it. Okay. Open recent. We got Simon, right? There we go. All right. So last time we wrote this simple function for our baby Simon language, where Simon is is either a literal expression, a var expression. Actually, we have this in code somewhere, don't we? So I think we just named it. Here we go. So here we go. We have here's our BNF for Simon. Simon is a lit expression, which is just a number. It's a var expression, which is a symbol, an ID. It's an if expression where it's if followed by an expression, expression, expression. It's a lambda expression, or it's an expression followed by is that asterisk? 0 or more expressions. So last time what we did is we wrote a function that takes things in Simon language. See, like kind of like sign language, but Simon language. Haha. All right. So like for instance, E5 is our most complex one. And what that does is it gives us this structure. A structure that says we're looking at an app expression, where that app expression has in it a var expression and another lambda expression. It gives us kind of the secondary version of these guys. So we're replacing normal syntax with lists of the types of expressions they are. And what we were supposed to write for our homework assignment is unparse that. That is to say, take whatever gets returned by this. Well, here. The idea would be that unparse Simon of parse Simon E5 should ultimately boil down to just E5. So unparse should take the output like this, or take that as an input, and produce for us this.
Oh. It's not bad.
You even asked me, and I told you.
Well, after I went to bed. I just like.
So didn't you email me like at 1 in the morning?
Yeah.
And I replied back at like 6.
Well. You mean good?
I mean, I'm not saying it was. I didn't reply back like at 3 p.m. the next day, is what I'm saying. It was a pretty quick turnaround given sleep schedules. Okay, but does that make sense what we're trying to accomplish? I'm pretty sure at the end of last class I said, does that make sense what we're trying to accomplish? I kind of said the same thing, so there's really not an excuse for not knowing.
Joey led me astray.
Weren't you here last class?
Yeah. You still led me astray.
All right. So, we need to write unparse Simon. Define unparse Simon, is that how I spelled it down there? Parse Simon, okay. To be a lambda, that takes in a S expression. Da, da, da. That's a Simon expression. Sexpression? It's a sexpression. do I need to expand? Actually, that wouldn't be a Simon expression. We need it to be a here. Let's have it take in a P expression, a parsed expression, Pexpression.
We don't want to be expanded.
Now I have to think about these things in my head to make sure like the shorthand I use is like some inappropriate statement. Well, was this one going to be something bad too?
No, I just found it humorous that you used the word expand.
Oh, like okay. So, anyways, this guy's going to be a lambda that takes in a parsed expression and ultimately unparses it. All right, so what are things I'm looking for? It's going to be pretty similar to what we did up here. So we're going to look at a cond. If null PEXPR, turn the empty list. If I'm not looking at the empty list, I must be looking at one of these other things. I'm either looking at something that says lit expression as the car, or var expression as the car, or if exp as the car, so on and so forth, right? So, EQV if I'm looking at a lit expression, what do I want to boil down to? A lit expression is just a number. So as an example, here's a lit expression. So I want to get the catter. So if I'm looking at a lit expression, return the catter of PEXPR. That'll give me the number. So a lit expression would be this. I'd be looking at something like that. The car of that is lit exp, and I'm going to boil down to just the number version of that. I'm unparsing the parsed version. That make sense? That should turn into just a 5. Else, if I'm looking at a var expression, a var expression should be just a ID symbol. Here's an example of a var expression right here. What do I want to do? I want to boil down just to the var. So I'm going to have that guy also be the catter. My solutions typically are. Oh, Dean, you didn't share with us your solution to the quiz.
You don't want to know. You can look at it later in the class.
Well, I'm guessing it was just parentheses. A lot of them.
No, I took some.
I took some artistic. All right, so next, if I'm looking at an if expression, I'm looking at an if expression that is PEXPR. That sounds like a supplement, doesn't it? Sort of does. PEXPR. All right, so if I'm looking at an if expression, for example, I can't highlight this. Just whatever. Just here. Look at an if expression. I'm going to have a we have it taken in a list, right? So an if expression is followed by a list containing our three expressions. That make sense? We did that last time. Okay, so that means that I need to then call. So I'm going to create a list. I'm going to boil down to a list whose first element is if, whose second element is unparse Simon, and then I need to pass it. If I take the cooter of my if expression, I'm going to be left with a list containing a list. Does that make sense? I'll be left with the list containing this guy. So the cooter of this is that guy. And what do I want from that? Actually, I'm sorry, I'm lying for a second. It's the list whose contains one element, where that element is that list. That's what the cooter of an if expression is. It's a list containing one element, where that element is a list. That is what I have highlighted there. So I want to call unparse expression, or unparse Simon, whatever we called it, on the car of the cooter. Right? Car of the cooter. So here, let me just kick this down line. So we'll call unparse Simon on the car of the cooter, pex PR. I'll call unparse Simon on the car of the cooter, pex PR. Right? So if I have a list containing a list, and I take the cooter of that, I get the list. Actually, I'm lying. If I take, here, let's just do it this way. The car of that will give me the list. The car of the car will get me the first element. Car of the car gets me the first element. Second element, if I take the car of the car gets me the list. The catter. That, right? Gets me the, and the last one is unparse Simon, the car of the cooter, the cadadar. Right? Just want to give myself a, so that's what it would look like. So the A would be the, so let's just say this guy's called LST. A would be the car, that's the list, the car of LST is A, right? So I'm going to take the car of this guy and then take the car of that guy. That gives me the A. To get the B, I'm going to take the car of that guy, which gives me the list. Then I'm going to take the cooter of that guy, and then I'm going to take the car of that guy. That gives me the B. Except I'm missing an R. The C is I'm going to take the car of that list. Then I'm going to take the cooter of that list. Then I'm going to take the cooter of that list. So I'm going to take the car of the cooter. And that gives me the C. right? Go ahead.
Comes out undefined.
Yeah. It's because the cooter of this.
Get the car of the cooler.
I always
It's
need
like
to.
A is a list.
The car of the. I think we're trying to be too nice about this. If I take the car of LST, I get this guy. If I take the car of that guy, I get what I want. If I take the car of LST, I get that guy. If I take the cooter of that guy, and then I take the car of that, I get the B. If I take the car of LST, I get the list. If I take the cooter of that, I get the list BC. If I take the cooter of that, I get the list C. Oh, hello. And if I take the car of that, I get the C. So CADDAR. Yeah, that's what we had in there, right? CADDAR. This should work. And this one should be CADAR. CA. This should be DAR. Yeah. Hold on. I just have to read what I said. This one should be CADDAR. CADDAR. That's correct, right? Then CADAR is correct. CADDAR. CADAR. CAAR.
Doesn't car only return a symbol though?
Yeah.
So what if?
Well, no, hold on. That's wrong. Car doesn't return a symbol. Car returns the first element of a list. In this case, the first element of our list is a list. The first element of LST there is a list.
Like when I tried that, I kept getting errors. So
Well, you weren't trying it this way.
I did the car of the cat, and that got me the first time. For what like
Is this guy still alive down here? Can I? Yeah, but I think I can do it this way. I think this is enough. So if I say define LST to be the list containing A, B, C, like that. And then I say CAAR LST, that gets me the A. CADAR LST, that gets me the B. CADDAR LST. CA. Oh, it's not defined. That's what you were saying. Well, that sucks. I can't keep using those?
What if you skip the last A?
We'll just take the car of it. So take the car of the CDDAR.
The CADDR.
Oh, no, this will work. It just kind of sucks that I can't stream a bunch. Can't do the stupid shorthand. All right, so I need the car of the CDDAR. like that. So that's what I'll do for an if. Make sense? If I'm looking at a, what's the next kind of expression? A lambda. So if the lambda, well, if the car of my PEX PR is a lambda expression, then I need to create a list whose first element is a lambda, whose second element is a list containing identifiers, right? But now if we look at a lambda expression, we have it down here somewhere. Here's a lambda. So for a lambda, we have a list whose first element is a list containing those things. So we have a list whose first, well, I'm sorry, let's do it in order. We have a list whose first element is lambda exp, whose second element is a list, whose first element is a list with some symbols in it. So I need the car. So if I take the cooter of this guy, I get what? I get the list containing this list as the first element. So it'll look like this. If I have a lambda, I stored a list containing a first element is lambda exp, whose second element is a list, whose first element is a list of IDs, whose second element is an expression. So I need to do pretty similar to what I did down here. I want the car of the car of LST. Of PEX PR in this case.
Can you look at the output again?
Which output?
Just go up to
Here, let me copy it just to another screen real quick. It'll be easier for us to look at. Okay, so we have lists containing first element is lambda, then a list whose first element is the parameters and whose second element is a list. Well, second element is an if expression with those three expressions.
for this in the if you actually have to have another. You have to start with the equation.
Well, if this is LST, let's just say that's LST. The car of that would be the lambda, right? Car is the lambda. The cooter of that would be the list containing a list ABC. Well, the cooter will be a list. There's the list.
Oh, yeah.
And it's going to be the rest, which is a list, where the first element of that is a list ABC. And the second element of that is an expression, a PEX PR, one of those guys. So if I want to get this list of that, I need to take the car of this guy, which will give me that, then the car of that guy, which will give me that. Car of the car, right?
Of the cooter.
Yeah, car of the cooter. That.
So all the ifs you also have
The who?
the ifs. There you have to put a
Car of the cooter.
You were just looking at the cooter from the
No. No, this is correct.
The car is the if. And then you have the list of the three expressions.
I'll copy the if statement here. So here's my if. So this is my if. The car of that guy is the if expression, right? The cooter of that guy is a list containing a PEX PR. It'll be It'll be a list containing a PEX PR, another PEX PR, and another PEX PR, like that, right? So to get the first element of that, I'm going to take the car of the cooter. No, car of the cooter. That's what you're saying, right? So the car of this guy, well, the cooter gets me this. The car of that gets me this. The car of that gets me this. Right? Oh, the problem is I didn't accurately represent it. I didn't have the if in there. Car, the cooter. This is the car, the cadatter. It's going to let me have one more D. Probably not. You sure? You tested it?
Yeah, you can have 3 letters in the middle.
Okay, so I need to take the cooter of this. Does this one work? But this one works. Okay. So, so now we need the car of the cooter. PXPR is our first guy, right? For our lambda. That gets us our parameter list. And then we need to get the body, which is this guy. So that will be the take the cooter, take the car. CADDR. Okay, so if I take the cooter of the first original list, I'm left with this list. If I take the cooter, actually no, I need to take the car of that then. The car of the cooter. Car LST gives me, the easiest way to do it is just walk through it like this. Car LST gives me the lambda. So I want the cooter. Cooter LST gives me the list containing my list. What I want to do with that, I want to take the cooter of that guy. No, actually, no, I want to take the car of that guy, which gives me the list. That gives me this guy. The list whose first element is the list ABC and whose second element is a P expression. And now I want to get the second element, so I'm going to take the cooter of that list, which gives me the list containing the second element, and then I want to take the car of that list, which gives me the second element. CDADAR. So the car of the cooter of the car of the cooter.
And I like before you can do all of that.
What?
So CADADR. So we're going to call unparse Simon on CADADR. PEXPR. And create a list there. That's what we do if we're dealing with lambda. Otherwise, we're dealing with a list containing an expression followed by 0 or more expressions. Correct? Well, actually, sorry. Otherwise, I'm dealing with something that starts with an app exp. So we'll kick it down. EQV, app, exp, car, pexpr. So if we're looking at an app expression, what am I going to produce? I'm going to produce a list of expressions, which is actually what? My second guy here. Now, did we put rands in a list by themselves? To look at how we actually wrote app expression. Well, I know that. I'm just saying I want to know what our output was. For an app expression, we created, so we have the word app expression. Then we have a list. So you don't have a simpler app expression later on? No, I don't. So the first element in here is going to be a list. And the first element of that list is my rater. So there's my operator. So that's just going to be a variable expression. Second element of that is a list containing my operands. So ultimately, I want to produce what? I want to produce a list containing my operator and a list containing, followed by my operands. Well, this is actually a kind of a fun way to handle this. So what are we going to do is we're going to create a list. The list is going to have as its first element the car of pexpr. But what are we going to do with that? We're going to call unparse Simon on it, because that guy's an expression. Oh, yeah, you're right. Car of the Cutter. And what am I going to put onto that list? What's my second element going to be? Well, I need to map unparse Simon across the rest of the list, which is going to give me a list, right? So let's do that. Let's do map unparse Simon onto, we need the car of the Cutter, pexpr. No, actually, it's that's not right. Kadar. That of pexpr. Is that right? Okay. I need the cadaver. Okay. What will that give me? That will boil down to a list, correct? So if I use this function here, I'm going to have a list whose first element is this guy, and whose second element is a list. But that's not what this wants it as. This wants it to be a list containing one or more expressions. So what could I do to this to fix it? Cons those together. Second element's a list. It'll build one big list. So if this works, we should get this line printed twice. Didn't like that. So we need the car. Gosh. It would be so much easier just to write these normal. So what do I want to do here? Let's just rewrite these. All right. So for the if expression, what do I want?
That was for the regular parse.
No, this is for our if expression. Oh, you're right. What's up with that?
Isn't that working?
You're supposed to be someone who did not go to class.
Oh, it's like confused by indentation. Yeah, I had to have. There we go. Okay. So I need the car of this guy. So yeah, so that's back up at parse Simon. That's interesting.
I see a
DDR. You need to play some of that.
Well, no. This is a function that worked before. Did it not?
I also have.
I have one in class.
I think we added another D.
does.
It's not, but it will be.
So maybe that one was right already.
Oh, like I came up and I added. Well, here, let's just leave it like this right now. That way we can go back and fix it right at the beginning of class next time. Otherwise, we're going to leave it in this like messed up state. Well, what I ultimately want to do is I just want to come in here next time, and rather than try to come up with these stupid ways of writing all these CADDD things, I just want to write it as cars of cooters of cars of cooters, and it'll just be clear. That's the easiest way to write it. All right? So we'll come back next time and we'll look at it that way.